It is time, so let us start the External Advisors meeting. I'll be chairing this meeting. I am Chairman Yamanaka of NRA, the Nuclear Regulation Authority. The Nuclear Regulation Authority has commissioned experts with a wealth of experience from overseas to serve as nuclear regulation external advisors to receive advice on various issues. And we've been holding the meeting basically twice a year. Face-to-face meetings were not held in 2022 or 2021 due to the pandemic. But we resumed the face-to-face meeting in May of last year, and today we are meeting face-to-face again. I would like to briefly introduce the external advisors attending this meeting. Mr. Richard Meserve is the former chairman of the U.S. NRC. Ms. Dana Drabova is the chairperson of SUJB, the Czech Nuclear Regulatory Authority. Mr. Philippe Jamet is a former commissioner of the French ASN. At this meeting, we would like to have discussions on ways to ensure safety of long-term operation of nuclear power plants. We have distributed notes for discussion, and I would like to focus specifically on physical aging of facilities and equipment and obsolescence, non-physical aging. Regarding the extension of the operation, amendments to the nuclear reactor regulation law are being deliberated at the National Parliament, the Diet, and specific discussions are being held at NRA as well. As this is a valuable opportunity to hear from expert advisors, the external advisors, we expect to have a frank discussion. So let us start the discussion on physical aging of facilities and equipment. The issue is also mentioned in the notes. For example, when operating a nuclear reactor for more than 60 years, to what aspect of aging should we pay attention? And what kind of balance should regulators maintain between the licensee evaluation results of individual SSCs and confirmation of licensees' quality management program? So I would like to invite comments from the external advisors.
Oh, hello. Okay, good. Well, my experience is in the United States, and of course, as it turns out, we have a lot of experience with aging plants. There are 92 operating reactors in the United States, and the average age of those reactors is about 40 years. And under our law, the initial licensing period was for 40 years, but the Atomic Energy Act allows a so-called license renewal process in increments of 20 years. So after you have a 40-year license, you can get a license renewal to 60 years, and then at 60 years, you can ask for another 20 years. It turns out that most of the fleet has had license extension to 60 years already. Not all of it, but most of it. And in fact, 6 plants have been approved with a license renewal to 80 years. And about 9 or 10 plants have filed to seek license renewal to be able to operate for 80 years. Now in the US, that's calendar years. It's not operating years. Now I think what the most important point I'd like to make about these reactors is we have a lot of experience, obviously, with aging reactors. Some might think that over time, the reactors deteriorate, that once you've turned them on, that they're inevitably must decline in safety. And in fact, the experience is quite the opposite, that we have monitored the safety performance of these plants. And over time, the numbers of scrams of the reactors, that's machine shutdowns, the radiation exposures of workers, radiation releases, chemistry performance, forced shutdowns of the reactors. All that data has been maintained, and the trend lines of that experience is for steady improvement of the metrics over time. And in fact, when these reactors were initially operated, the capacity factors might have been 60%. Now the average capacity factor in the United States is over 90%, so they're operating better. So I think that the point I'd like to make is that, in fact, we have learned to run these reactors better, and why has that happened? It's in part, of course, by upgrades that have been made. It's a result of operational experience over time. It's an emphasis on safety culture. It's just basically a improved management and training of the workers. So that's a large number of factors that could explain it. But the important point to make is that aging does not mean that the safety margins are reduced. And in fact, the data would suggest that the safety has improved over time. So the idea that reactors must inevitably deteriorate is not necessarily true. It could, but if you're attentive to preserving the safety margins, these reactors can operate safely for an extended period of time. Let me turn to my colleagues to make some comments.
Okay. Thank you very much, Richard. What Richard said, I fully agree with. I mean, I think there is a bonification of the safety of reactors with time, and this is what the numbers are saying. The only difference between what was described up to now and at least the French approach is that in addition to taking into account the operation, in addition to having progress of safety due to the fact that the teams and the operators know better their installation and are progressing, there is an additional thing that we do, which is to implement modification in order to reduce the gap between existing reactors that are operating after 40 years, in the case of France, and the newest reactor, such as AP1000 or EPR in France. So we do take into account aging, we do take into account operating experience, new knowledge, but we also try to upgrade as far as reasonably achievable the design of our reactors to reduce the gap between newest reactor and old reactor that are going on being operated. To a certain extent, this is the French understanding of the European Directive on Safety, which stipulates that continuous improvement should be done through the time. Thank you very much.
Good afternoon, everybody. It's my pleasure to share with you a piece of information concerning the situation in Czech Republic. In Czech Republic, we have 6 PWR reactors in operation. 4 of them are approaching 40 years of operation, and the 2 of them are in operation for 20 years. That means for those 4 reactors I have just mentioned, they entered already long-term operation, which was supposed to start after 30 years. And important thing is, in my opinion, that in the Czech Republic we have no limit, no time limit for long-term operation. Our approach is based on so-called periodic safety reviews in 10 years intervals, and after this very tough, very demanding and really resource and capacities demanding exercise, there is a decision of a nuclear regulatory authority to allow continuation of operation. As it was described in materials NRA provided to us, their proposed system, new system, is very similar to what is usual in Europe, not only in the Czech Republic. That means to use periodic safety review as a very efficient tool for both the operating organization and regulatory authorities to guarantee high level of safety. So it will be very useful for us as external advisors to share further information or experience with our Japanese colleagues about their intentions. But I would conclude for the time being that the proposed system is really quite similar to what we are used to use in Europe and in Czech Republic, of course. And the other important piece of information is that all this would be based on the agency safety standards, I mean International Atomic Agency safety standards and guides, what concerns periodic safety review and its content. Thank you.
Thank you very much. We have just heard from the external advisors, and the commissioners on the NRA side might have questions or comments. Anybody have any questions or comments, please? This is Sugiyama speaking. I'm a commissioner. Well, first of all, thank you very much for your comments. I am greatly appreciative of your comments, especially towards the end. Ms. Drobova mentioned that this new system that we are trying to introduce in Japan, where from 30 years of operation, every 10 years, we will have aging evaluation assessment, and also we will evaluate the conformance or conformity to the requirements. And that is similar to the periodic safety review that is used in Europe. Of course, we are referencing the IAEA safety standards or guides, and therefore we are following or modeling our system after how things are done in Europe. And the fact that you mentioned that the system will be effective is encouraging. But of course, for that to translate into ensured safety, just introducing the system is not enough. The regulator and the licensees need to make their respective efforts. And in that sense, we have to do our job of regulation. So thank you very much.
Agree. The reality is that both the licensee and the regulator have to be fully engaged in ensuring if there is a license renewal, a license extension, that the safety margins are maintained. I should add that I think although our review is after 40 years and after 60 years, for the increment, so it's a longer time interval, there's a very extensive review that is undertaken that's led off by the applicants submitting information that's evaluated by the regulator to assure that, that the operations can continue safely over the extended period. And we had a discussion earlier about what the evaluation covers, and we're in a common accord that one is looking at the possible deterioration of the concrete, the corrosion effects that occur in the plant, the possible degradation of cables, the radiation exposure of the reactor pressure vessel, thermal cycling fatigue. There's a whole series of things that are affected by age that may not have been evaluated as regularly over the course of operations, but have to have detailed scrutiny at the time of the license extension. And that involves, as you've indicated, very extensive efforts by the licensee to provide the necessary information and a thorough review by the regulator to be satisfied that the safety margins are maintained.
Sorry. Okay. Yeah, I have three small remarks after what Dick said. First, for the time limit, I was very interested by this meeting because sharing experience made me realize that there are different systems in the world about time limit. There are, like in Europe, systems where you don't have initial time limit, but you have to check every 10 years that the plant is fit for more operation, 10 more years of operation. And in the US, you have time limits, but on the other hand, at the end of the time limit, you can extend it to another time limit. So in summary, what I would say is that fixing a time limit doesn't stop the plant at the end of the time limit. Actually, the plant can be operated as long as it is safe. And therefore, if a time limit is fixed, actually, it's not a safety decision. It's only an energy policy decision, at least a politic decision. So I think this was very interesting in this meeting. Considering the physical aging, I think I want to insist that it's true that we agreed on the main mechanism. If I had something to remember is that if we are thinking about really long-term operation, the feeling is that the two structures that will be really critical are the vessel and the confinement. This is not true, not the new statement, but this is fine. And I think I will stop for this. Thank you.
If I may, small remark what concerns pressure vessel aging program. In the Czech Republic, we have quite similar surveillance program through witness, so-called witness samples, as it is established in Japan. And this is a very useful tool when assessing the remaining lifetime of reactor pressure vessel.
Could I add one additional point? So we had an interesting discussion about an additional element that could arise. As we all are enduring right now, we are dealing with climate change. And climate change is changing the circumstances in which the plants will operate. And perhaps an additional factor that warrants at least some consideration is an evaluation of what the changed environment in which the reactor might confront over an extended period of operation. One can imagine, for example, that as an aspect of climate change, there'd be sea level rise, high winds that could propel things into the plant, higher winds than be normal, floods that arise as a result of extreme weather. We talked about the salt degradation of concrete and that the typhoon might bring salt onto the concrete. It could result in accelerating the degradation of the concrete. Snow loads could increase the vulnerability of the buildings. So there's a bunch of additional factors that may be appropriate to consider that are as a result of the changing risk that we all confront more broadly across all of our societies as a result of climate change.
と少し
Okay, something technical, if I may. I'd like to answer something technical here. About the pressure vessel, the neutron irradiation embrittlement was referred to. On that point, in Japan, yes, in a similar fashion, the degradation mode, or one of the key modes, is exactly that. We are considering that. And in Japan, right now, we actually conduct a very thorough inspection at 40 years of operation, and then after that, additional 20 years might be allowed.
And we have the accelerated aging specimen placed inside the reactor so that with the radiation of actual 40 years, we can predict the embrittlement over 50 years or 60 years. So that kind of testing is already available. So when the radiation is to continue for 50, 60 years, then we can get the data for 70, 80 years of irradiation. We have that kind of system in place already. And I expect that that is acceptable. Regarding BWR, compared to PWR, the radiation level would be one order of magnitude or 2 orders of magnitude smaller. So I think the impact of irradiation would be lower. Any other questions from any other commissioners? Yes, thank you. Regarding the climate change that you mentioned, the sea level rise, and strong winds, high winds, and also the salt impact of concrete and alkalization. These are the things that we have to pay attention to. And of course, the situation of concrete would be different depending on what materials are used, especially the matrix. So we need to pay attention to that. Now, what you mentioned in your initial remarks, Mr. Meserve, in France, the modifications are done, whereas in the U.S., not just the upgrades, but operating experience and safety cultures are really taking hold, and trainings or improvement. You said that these are contributing to improved level of safety. Can you elaborate on those points again?
Well, let me say that what we observe is the data shows that a variety of metrics show improved performance over time. That things like the number of scrams. Scrams, one time, were very common in the early days of the reactors, and now they're very uncommon. So we've learned how to run these reactors, and every scram is a challenge to the safety system. And so you don't want to have scrams if you can avoid them. So it's the data would show that the plants are performing better. Now, I speculated as to what the reason was. The speculation was that it's a variety of things that have improved that could affect the safety performance. It's operating experience, it's improved training, upgrading of equipment that's going on, safety culture. All of those are factors that one might point to as contributing to the improved data. But I can't point my finger and say it's this or that that caused the improved metrics. I'm speculating as to what the cause is. And there may be many things that probably all of them work together to contribute to the improved performance that we see.
Any other questions or comments from the commissioners? Yes, please go ahead. Thank you. My name is Ishiwatari. Natural hazard evaluation is my area of expertise. 40 years, 60 years of operations that we've been talking about. The limits would be removed going forward, and there is an act on reactors, nuclear reactors, for which NRA is responsible for. The law is going to remove the limits from 40 years and would be replaced by a different set of laws. So why is it that this conditions were included in the act to begin with? Well, the 2011 earthquake, tsunami, and the accident at Fukushima Daiichi, based on the lessons learned from those experiences, 40 years, 60 years rules were incorporated in the act. That is my understanding. So as far as I'm concerned, these time limits, the act that we are responsible for are going to have those time limits be removed. I cannot support that idea, and therefore I oppose the amendments to begin with. And due to tsunami, Fukushima Daiichi caused the accident. And what that represents is that the Japanese archipelago, regardless of where you go, there is a likelihood, there is a possibility of affected by major earthquake, as well as a consequent tsunami. Since many of the nuclear power plants in Japan are located along the coastlines, they are prone to tsunami, and we have many active volcanoes as well, and that could have impact as well as enabling the active faults. So given those factors, since I am responsible mainly for those natural hazards, I have a grave concern. The safety of nuclear facilities, I have responsibility over the safety of nuclear facilities. And therefore, even if the time limits have been eliminated, I think NRA should continue to be engaged in rigorous evaluation of safety. We have been doing that, but I think that should be maintained and even strengthened going forward. So on that subject, please keep in mind the natural environment in Japan is quite different from the continental countries. Please keep in mind that in Japan, we have those risks associated with where we are located, and that should not be neglected. So please keep that in mind. That is all I wanted to say.
I almost fully agree with you, Commissioner Ishiwatari. Nevertheless, I would like again to remind all of us that the periodic safety review is a very efficient tool how to handle changing conditions, even the changing conditions in natural extreme hazards. And because, in fact, nuclear safety and the guarantees of nuclear safety are never-ending story. We in a way, learned a big lessons after Fukushima Daiichi accident to re-evaluate and re-evaluate what can be, what could be forgotten or omitted in the initial assessment. And that's what why we have, in my opinion, this periodic safety review with very tough content of evaluation. And really, I think that the first duty of Nuclear Regulatory Authority is ask and ask again licenses, but also the staff of regulatory authority itself. What could we forget and what could we do better?
I very much agree with the comments that Dana has made, that you have an abiding obligation, regardless of the term of the life of a reactor, to assure that it operates safely. And that includes a complete evaluation of all the risks that arise. And obviously, that can be site dependent, that you have different seismic and typhoon and tsunami risks from site to site. And that should be part of the evaluation that goes on for each plant as a continuing obligation of both the licensee and the regulator. I see the question of life extension, however, the term of the life is presenting a somewhat different question. The reason is I can point to the United States on this, is that the initial period of 40 years life was not based on any safety concern. It was based on an economic evaluation that caused them to establish a law that said 40 years. It wasn't because there was some judgment by the Congress that safety is changed by the license term, as I've indicated. In fact, it may even be improving over time. But that doesn't take away the fundamental point you're making, is that the regulator in Japan, as that every regulator, needs to assure that the plants can operate safely, and that's regardless of how old they are. That's a continuing obligation that must be satisfied.
Okay. Thank you very much for your intervention. First, I just want to, we are conscious that external events, and especially extreme external events, are really a threat for safety. And you probably know, but in Europe, huge programs were carried out after Fukushima. And to give you an example, in France, we have we have increased by 50%. I don't remember the name in English of the earthquake that is the maximum you take into account, and you have to demonstrate that there is no OB. No, it's the complementary of OBA. Anyway, we have increased by 50% the level of the earthquake without really, scientific basis, just because we acknowledge that there is a lot of uncertainty in predicting extreme natural hazards. And then we have implemented modification like electrical supply that could withstand this, pumps that would inject water, and so on. So this was very costly, but the big lesson for us is that even though we make very serious studies with geologists, people, specialists of tsunami and so on, we think we can underestimate the risk. And therefore, we did what was the maximum we could do given reasonably, inside of reasonably achievable measures. Now, saying this, we are still conscious that extreme natural hazards is one of the most important threats. And if you look at PSA, now it's what the PSA are showing is that this is the main contributor of the risk of core melt and releases. So this is it. It's much, according to the PSA at least, this is much more important than internal failure. So we know about this. And I think we have to acknowledge that there is still a risk with operating reactor, even though you've made a lot of things. You cannot say a new accident will never happen. And most probably a new accident will sometimes happen. I mean, this is, and therefore, altogether, the decision, when we make the decision to allow operation, we know we take a risk. And this is a fact of life. And then it is a policy decision, whether the society, for its comfort, its industrial development, and so on, is accepting this risk. The only thing that is new since some years is that now we have climate change. What do you choose between climate change and the risk of an accident? This is, I think, fundamentally one of the big elements of the background. And as a regulator, you have the responsibility to find the best possible choice between the two, risk of accident or climate change and continuation of the development of your society.
Thank you very much. Yes. As was mentioned, as Mr. Ishiwatari mentioned, regardless of the life, or we will not take light of the natural hazards. More stringent Asian management regulation or system is what we're trying to introduce. And I have two last questions on this topic, if I may. First, daily sort of degradation versus aging degradation. In other words, degradation that occurs over longer time. In other words, those degradations that are more related to LTO. How do you draw the line between the normal type of degradation that occurs on a daily basis versus long-term operation? So what are some of the countermeasures that you're taking with regard to those different kinds of degradation? My second question is, how do you identify new degradation types? What are some of the measures or innovation, maybe, that you're employing in order to identify new degradation?
I don't have an easy answer to that question, as I think that it's the obligation of the licensee and the regulator to be constantly striving to improve safety. And that includes assuring an awareness of threats as they may evolve. It's conceivable over time that there'll be some degradation mechanism that we have not understood adequately in the past and may be accelerating over time. One would expect that, you would be performing the basic science so you understand the physics and chemistry of the degradation mechanism and that you're monitoring it so that if something unexpected arises, that you have detected it and ideally detected it soon enough that you can introduce measures to bring it under control or, if necessary, replace equipment or what have you. So I think that it's just a part of a fundamental obligation that the licensee and the regulator have to see that safety is their objective and remaining open to the possibility that there may be some surprises that arise that require action.
Yeah, I have a complementary. I think one very important way to identify new degradation or new location of degradation, is when you see something to ask the question, could what I see happen somewhere else? And we had recently, you've heard probably, problems in France where cracks were detected in the safety injection system. The first cracks were expected and they were detected because we knew there was thermal fatigue due to flow and mixture of water. And then once two were detected in a place, the question was, is it possible that this happened in another place? And the French regulatory authority ordered quite a few controls, and then they discovered another one, a third one, that was much more important than the two previous ones, but it was a different mechanism. It was ISCC, and it was due to stresses that were created by a realignment, you see it correct, of two pipes when they were repairing a weld. So I think if you have a very extensive interpretation and consequences of any event, thinking, okay, I have this here, could it be a sign that there is a more generic problem, or could other structures be affected, is one thing. The other thing, of course, is there are places in reactors that are not easily accessible. And when you control for aging, it's not easy to go. And just for your information, when the French regulatory authority gives the authorization, in principle, to go beyond 40 years, they put a conditions that two plants that are actually stopped and will be dismantled, the two plants in Fessenheim, will be very carefully examined from an aging point of view, and specifically in places that are difficult to access. And this is just to make sure that they were not unseen mechanism or structure or non-considered structures that could be affected by aging.
Only a short remark, if you allow me. We can more and more benefit from robotics and also development in non-destructive testing methods. And we should do that because the potential of those new tools developing quite fast is substantial, especially in finding possible new degradation mechanisms, and also in how to say it properly, fitting our previous models to the reality. So we should really not hesitate to use the state-of-the-art methods.
Thank you very much. Okay, in the interest of time, I would like to suggest that we move to the next topic, that is obsolescence of design. In other words, non-physical aging. Over time, the technology will become obsolescent, and the systems and regulations might become obsolete as well. And the knowledge obsolescence is another aspect. And if there are technologies that can be expected to improve the performance, should the regulator encourage the licensees to adopt such technologies? And also, how should regulators be involved in terms of addressing the unknown unknowns? I'd like to invite your comments on these aspects, please.
Well, let me comment that the approach to the United States on these issues is somewhat different from what my colleagues will describe. We have a different kind of backfit obligation, that when there's a possibility of a new regulatory requirement being imposed, the initial judgment is whether that regulatory requirement is necessary to assure adequate protection of a public health and safety. And if it is necessary to assure adequate protection of public health and safety, it's mandatory. And every licensee is obliged to follow it. So if there's new knowledge that arises or new technology that comes forward that offers you the opportunity for improvements, you make a judgment as whether that the incorporation of that is necessary for assurance of safety. But there are many changes that arise that are not necessary to provide adequate protection of safety, but would be nice to have, perhaps. And in that case, in the United States at least, we do a cost-benefit analysis and examine what it would cost to introduce that change versus what incremental improvement in safety would be allowed. And you look at that balance and you reach a judgment as to whether that's necessary. So I think it's the core ingredient here is there has to be judgment that is made on whether a new requirement should be imposed. I mean, I take the analogy of an automobile. You don't throw out your old automobile because one may have improved safety features associated with it. You make the regulator, in that case, may make some judgment. It's okay to let those continue to operate for a period of time anyway. And so you have cars that may not have the latest technology in them, but are deemed to be sufficiently safe that we can continue to use them. And sort of the same philosophy, I think, has to apply that it's certainly the case that one could imagine an advanced reactor would be safer than an existing reactor. In fact, the vendors would claim that they are safer. And the question you have to ask yourself, does that mean we should throw out all the old existing reactors and replace all of them? Well, that would be punitively expensive to do. So there's a judgment that would have to be made as to whether the obsolescence gives you enough advantages to be worth the cost of making the change.
Okay, I think I'm not going back to this story of backfitting. I think it was clear enough that for us, public protection has to increase. It's not a stable limit, and okay. But now I wanted to go to a more modest subject about available new technologies and what should the regulator do if he thinks this has a potential. And I'll take an example. You can have storage of spent fuel in pools, or you can have storage in a dry gas, okay? First, this is a subject where studies have been performed by the French TSO IRSN, and it shows that both solutions are possible, but dry storage might be interesting. Now, I don't think the ASN at this time has taken any step, but suppose if the French regulatory authority wanted to promote this idea, I think the first thing they would do is to ask the utility to make a report comparing the two solutions. Because overall, the choice relies with the utility. And from this report, then they would assess it and possibly go on trying to push the technology. But I don't see, without a position from the utility, the regulatory authority imposing a technical solution, because this would be outside of its mandate and role and responsibility.
If you allow me, I would like to mention another aspect, which is not exactly the obsolescence, but it has to do with it. And this is knowledge management and the transfer of proper knowledge from generation to generation. What concerns both the staff of operating organization as well as regulatory authority. And I think, and we can see it clearly in Europe, but not only in Europe, that the whole nuclear community, including the regulator, is in the process of generation shift, and the big big issue is how to maintain the proper knowledge basis, not only be able to train the newcomers how to do things, but also to be able to explain them why it is necessary to do things like described in manual, the reasons that are behind. So not only to teach them how, but also carefully transfer to the extent possible the knowledge why.
Thank you very much. Any questions or comments from the commissioners? Yes, please go ahead. Thank you very much for your valuable input. Obsolescence of design. Of course, when you compare new design and older design, newer designs have better safety, of course. In Europe, you use periodic safety review system so as to fill the gap, whereas in the U.S., as Mr. Meserve said, excluding the forcible imposition of backfitting, you are not really imposing the need for the efforts. So do I understand correctly that even without such enforcement, the voluntary efforts are being made by licensees to improve the things? And if that is the case, what are the motivation, what are the incentives for the licensees to voluntarily improve the technology?
I hope you understand the purpose of my question or intent of the question.
I do. Let me say that we do encourage the licensees to always be improving safety, that they see that, we want to have them see that as a possibility. And in fact, I think it's often a strong motivation for the licensee to take voluntary action so they don't confront a regulatory requirement. In fact, if somebody comes forward with an idea and then you make it a regulatory requirement, it may be disincentive for them to even propose the idea, for fear that it then imposes a regulatory requirement which they may be comfortable but other licensees would not be, or might not even be appropriate for them. So I think that the encouragement of voluntary incentives is already there, because most licensees would prefer to control their own life rather than have the regulator direct everything. So that there is incentives for self-improvement that do exist among the licensees.
I would like to mention a very powerful incentive for the licensees, and this is the pressure from community, because nuclear power is highly the international thing, and people from nuclear power community are very well aware that the accident elsewhere is an accident for the whole nuclear industry. So this pressure from the community is, in my opinion, and I'm sorry for saying this, more powerful than any regulation.
I also think that I fully agree with everything that was said. I also think that if you send constantly the message that safety is a responsibility of the utility, and you disseminate this message as much as you can. This is also an incentive for them to prove that they take this responsibility seriously.
Be remiss if I don't mention one additional factor, is that we have the benefit in the United States of the Institute for Nuclear Power Operations, which is created by the licensees. And it states that its objective is to go beyond the regulations to assure the premier effort in favor of excellence on safety performance that extends beyond what a regulatory requirement is. And that is real. So we have the benefit in the United States of the backstop, or really the prelude that is provided by the INPO, which is enormous pressure on the licensees through various mechanisms to assure safe operations that are in excess of regulatory requirements.
Thank you.
設計の
Well, about the obsolescence of design, of course, there are different levels of obsolescence of design, and how to deal with that obsolescence is a challenge, a difficult challenge. One proposal that was made was a backfitting, and that has already been introduced in Japan as well. The biggest difference between Japan and the United States is that the safety significance is evaluated, and then introducing consider whether or not the requirement be imposed on the licensees or not. That it has been our thinking in Japan since the accident, but as of now, we have not been doing that. Now, as for the obsolescence of design, how to deal with that, we need to make sure that we check for unknowns, things that we may have overlooked. And we have this a periodic assessment of continuous improvement, which is almost equivalent to a PSR in Europe every 10 years. And in doing that, the obsolescence of design is checked to see if there is anything that has been overlooked in the past. So that is the approach that we are considering now. Any comments from other commissioners? The pressure from the nuclear community becoming or serving as the pressure, or the rather the incentive to the licensees. That was a really valid comment. Thank you. But actually, if we expect too much, have too high of an expectation to that pressure, that might not be a wise approach to take, in our view, because the utilities or the licensees need to identify the weaknesses of the individual plants. We need to order them to do that. And at the same time, we also need to find or get new insight, new knowledge from the various operating experience around the world. We need to really understand the knowledge ourselves. And then the regulators and the licensees both need to bring their findings together so that we can together understand the situation. And when we identify a challenge, yes, we have been conducting meetings on a ad hoc basis, but rather going forward, we would like to have regular meetings so that both sides, the regulators as well as the licensees, will always constantly think about those potential challenges and issues.
I think you're quite correct that there needs to be a lot of communication and interaction among the utilities, the regulator, the academic community that's familiar about the safety issues, and other stakeholders, so that there is the illumination that all the inputs can be focused on and considered in making decisions. And you're actually likely to get much more stable decisions because the people who have stakes in the outcome are involved in the process by which the decisions are made. And that's likely to give you not only better decisions, but decisions that are more acceptable to people because they've been heard, they've participated in the process by which the decision is made. So I very much agree with your point that having an open and transparent process as you conduct these evaluations is something that would help the credibility not only of the regulator, but the validity of the decisions you reach.
Thank you. Any other questions or comments? No? Well, not just aging, but enhancement of safety is something that the licensees need to be incentivized. And in that context, we've been talking about the community, the obligation or the responsibility of the licensees towards the community, and also the licensees need to have a very good understanding of the views by the community. And as an example of the United States, you mentioned IMPO, and NEI is another entity I think that will take part in the communication. In Japan, we have JANSI, which is the licensees organization, as well as Athena, which is another entity in Japan. And as Commissioner Sugiyama mentioned, in aging management, we would like to have a regular annual communication between the regulator and the licensees. And for enhanced safety or continuous improvement, we want to, well, we have been conducting meetings or having communications with the entire licensee community. And we need to make sure that we have an enabling environment so that the licensees can try to improve safeties on their initiatives, out of their own initiatives.
I hope our discussions have been helpful to you. I know we're reaching the end of our time, but I think that there are a lot of common threads of discussion among your external advisors and the views with which you're approaching. That basically the new system that's being proposed from Japan is consistent with the approach that's being applied more broadly across the world on how you consider the license extension, and that the role that you envision for the NRA in this process is one that is consistent with the perspectives that all of us bring to the issue. So I hope that our interaction with you has been productive for you.
Thank you very much. Yes. You've been kind enough to share with us valuable inputs. Thank you so very much. I'm afraid we're coming to an end time. Way to respond way to ensure safety of long-term operation of nuclear power plants was the topic. And we heard many comments. And all those would be used for the activities of NRA going forward. So once again, I'd like to thank the three advisors for taking time to travel all the way to Tokyo to give us the valuable input. Thank you very much indeed. And with this, I declare the end of the External Advisors meeting. Thank you very much.